This is Unit 5, Ratios and Percents, Lesson 2, Proportions. Lesson objective: to understand proportions, to determine whether two ratios are proportional, and to solve proportions. Vocabulary 2. A proportion is an equation stating that two ratios are equal. So if you notice, here are two ratios in the example showing that they are equal to each other. Vocabulary 2, multiplying the numerator of each ratio by the denominator of the other ratio is called cross products. 2/3 is equal to 8/6, x6. 2 to 3 is equal to x over 6. Cross products would be 2 times 6 or 3 times x. We're first going to talk about how to identify proportions. Now remember, the definition said that proportions are equivalent ratios, and one of the ways to write a ratio is in fraction form. So we can look to see if our two ratios in fraction form are equivalent fractions. The two ways that we can create equivalent fractions is by multiplication or division to show if those ratios form a proportion or not. In this first example, we have 4/10 and 12/30. 4 to 10, 12 to 30. We're going to use multiplication because I notice here on the left the digit is smaller and then the number on the right is greater, so that means multiplication was used. 4 times what gives me 12? Well, 4 times 3. If I do the same here, 10 times 3, does that give us 30? Yes, it does. That means 4 to 10 and 12 to 30 are proportional. They're equivalent ratios. Over here, we notice that our digits are larger on the right, or on the left, excuse me, and the digit on the right is smaller. Therefore, we're going to use division. So 12 divided by 3 gives us 4. Well, if I take 30 and divide by 3, does that give us 10? Yes, it does. Therefore, 12 to 30, 12/30ths, is equivalent to the ratio 4 to 10, 4/10. Then these two ratios in fraction form are proportional. The second way that we can identify proportions is using cross products. This says that if the two products are equivalent, then the ratios form a proportion. Now remember, cross products are when you multiply bottom of one fraction with the top of the other fraction. So here I'm going to multiply 4 times 30. 4 times 30 is 120. Then I'm going to go and crossways again our other denominator and numerator and multiply. 10 times 12 is 120. These do check out. They are equal to each other. Therefore, they are proportional. Let's take a look at some practice problems. Here they want to know, does each pair of ratios form a proportion? So basically we're going to say yes or no when we're answering. But in order to do that, we have to choose, are we going to use cross products or equivalent fractions, multiplying or dividing? When it is something larger like this, sometimes possibly using the equivalent fractions could be easier. So when I start here and I look at 4 and I'm going to 8, I know 4 to 8 I have to divide by 2. Well, if I take 7 and divide it by 2, does that give me 14? And if that checks out, then I'm going to answer yes, that those ratios form a proportion. Looking here at number 2, 5 to 10 here, going this way to look, 5 to 10, I would have to take times 2. So go down to your denominators. 2 times 2, does that give us 4? If it does, we're going to check mark it and we're going to write yes. Now if we have something like here, these are small numbers, so I want to just try cross products here. I'm going to cross multiply. 5 times 6 is 30. And cross multiply here, 8 and 3 is 24. 8 and 3 do not equal. So no, these don't check out. This is a no. These two ratios are not proportional. At At this time, you can pause the video and take a few minutes to solve practice problems 4, 5, and 6. Our next part is solving a proportion. In order to solve a proportion, we're going to cross multiply our known values and divide those by the value diagonal from the variable. So I know cross multiply here, 2 and 6, I know both those values. If I cross multiply here, I don't know this value, so I can't multiply them. So we're going to multiply these two values. So we're going to say 2 times 6, and then it says divide by the value diagonal from the variable. So this is the value diagonal from the variable. So we're going to divide by 3. Now you notice we have an order of operations problem here. We have multiplication and division. So when it's multiplication and division, we just simply work left to right. So we're going to multiply here. 2 times 6 is 12. Then divide it by 3 gives us 4. So x equals 4. Let's try that down here in the practice examples. Remember, we're going to cross multiply the values that we know. So if I look here, I can't take 10 times n because I don't know what n is yet. But I can take 5 times 2. So I'm going to cross multiply those, 5 times 2, and divide by what's opposite the variable. Well, 5 times 2 is 10. Divide it by 10 gives us 1. So our variable n equals 1. And then this is what I'm going to box as my final answer. Here on number 8, I'm going to cross multiply 9 and 3. Those are the values I know. So 9 times 3, I know those two, and I'm going to divide it by what's opposite. So this 27 here is opposite the variable. 9 times 3 is 27. Divided by 27 gives us 1. So here n equals 1. And then that is what I'm going to box. Looking at number 9, 30 times 9 may be a big number, but we can still do that. 30 times 9. And then we're going to divide it what's opposite the variable. So we're going to divide by 6. Well, 30 times 9 is 270 divided by 6. Now, if you can't do this in your head, you do have the use of your calculators. I do not have mine right now, so you can always go and do it the old-fashioned way. Put 270 inside. 6 does not go into 2. Bring down our 7. 6 goes into 27 4 times, which is 24. 3 left over. Bring down our 0. 6 goes into 30 5 times. Remainder 0. So 270 divided by 6 is 45. That means our variable a equals 45. Pause the video, take a few minutes, and complete practice problems 10, 11, and 12. And when you are done, this is the end of Lesson 2, Proportions.